Hello. My name is Thomas Klausner, I'm from Vienna, Austria. And I'm going to talk about a script or modular rules called TimeTracker. I'm also talking about metaprogramming and method modifiers, which is basically moose stuff. So this talk is going to be about an application we use about all the time, powered by some nice moose stuff. The first thing is time tracking. Everybody actually needs some sort of time tracking software, I guess, to figure out how much you can bill our customers. Also, it's even more important in my opinion to evaluate our estimates, because usually some guy asks you how long you take. Is it too small? And then you say, I have no idea, it takes 2 hours or 3 months to implement the feature, and then when you finish, you will actually want to compare your estimate with how long it actually took. And also to stop us from working too long, especially for me, because I'm usually working half-time, like 20 hours a week. And sometimes the coding is fun and you hack, and then suddenly you clock in lots of overtime, which you should actually spend with your family or on other projects. And probably some other reasons. Of course, there are lots of different solutions already available for time tracking. And in the spirit of this KCT comic, we of course did the obvious thing and did our own, based on the great saying, the more you do it, or the more specific, the more you want to do it, it finds best. So here's the example usually of the script. It's just what it can do. You can say tracker, that's the name of the script, and start, and just captures the actual time you are now. That's now, and as you start working on the thing. You can say current, what are you currently working on, and it reports how long you've been working on that task or that project. You can stop it and say, no, okay, I'm done with that. Then you're not working on anything. You can start again. Pick here, and you can have something like tags attached to the project you're working on. And you can also start a new tag, and then, of course, it does an automatic stop of the previous task, and then you start a new task. So that's the basic thing, and then you can have various sorts of reports and things to show how long you actually work on various things. But that's the boring thing. We store all of this information for each task in a JSON file. JSON becomes very easy and portable that everybody can read it. It looks a little like that. So there's a lot of some sort of attributes. It's also not very interesting. It's just a JSON file storing some information. But those JSON files are generated directly from our moose-based class, which is called TimeTracker data task. And most of the work is done by moose and moose storage. So if you want to persist a moose-based class, you can use a module called moose storage. It makes it very easy. So this is basically how how this task class looks like. It uses moose, has some bunch of attributes. Anybody of you know moose? Some people don't know moose at all. So that's basic moose stuff. We use moose, we use some attributes, and then we use moose storage, and then we tell it what kind of storage we want to use. In this example, we want to use JSON. And to be more specific, I want to use JSON.pm because that allows me to do some pretty printing and stuff like that. But you can also use just regular JSON, or you can use YAML or whatever. A lot of different storage backends available. You can of course write your own backend. So you just initiate one of those task things and then call the store method on it, which is provided by music storage, and it gets stored into a file, and that's it. So you don't have to it's very easy, not much work. One thing is missing: music storage can only stringify native moose types. What's the question? I thought we had somebody raise this hand. If you want to use other types, you have to declare how to stringify them using a custom type handler, which is like still, looks like this. It's just basically a simple subroutine you put into telling Moose how to store this data type into the string and how to get from the string back to the object. Like you would use in DVIC for inflator and deflator. One more handy Moose feature is a trigger. So we have an attribute called stop, which is a trigger, and it's called calculation. So every time we set an attribute into this attribute, if you set the stop attribute, the trigger is called, which you can use as other attributes. For example, so if you set something into the stop attribute, we calculate the duration, we work on this thing, and store it into other attributes. It's quite nice. Yeah, of course, the class has some other helper methods to retrieve and store all of the files, generate a file name. It's just basic, boring, but you can use this. So we're not using a database, not even SQLite, because it's very, very hard to synchronize a database between different machines, even SQLite databases. And it's also even harder to allow offline access to the database. So we did something like Git does, the great version control system, and store all our information locally on whatever machine in simple small files, which you can easily synchronize. And I'll show you how to do that. So that's all nice and shiny, but it's not very special. You can do something like that with add command or some other things. So what we actually wanted is a system that does more than time tracking. We also wanted to make it easy for us to stick to a good and proper workflow. And our workflow looks like this, and that's the meaning. Quite okay. You find a ticket you want to work on, or somebody says, hey, you work on that ticket. We're using request tracker from Best Practical, which is a very good ticket handling thing. There are different ones. Then you create a topic branch in Git, so you work on that feature or that bug or whatever. Then you maybe tell your co-workers that you're working on that thing. You hack, and then when you're done, you merge the branch back to master. You announce that you're done with this ticket, and you record the time you spend on this thing, on this feature or bug or whatever. So each of these steps doesn't really take long. You can just do it by hand, but it's just annoying and it takes up time and it's boring and it's something that has to be automated. So that's one of the things we did here. And of course, it would be very easy to hard code all of those steps into our time tracker, but it wasn't really working because my regular job, besides that one, I work on some other projects. Some are commercial, some are open source, some are completely private. Not all of them use request tracker, for example. Not all of them use Git. And not all of them want to spam my colleagues that are working on that. Maybe I want to work on some very secret hidden project that my colleagues should not know about. So we need some sort of flexible, pluggable application, and the behavior of this application should be different depending on the configuration and the context. So what we basically needed was to build a custom application from a set of available building blocks. And this sounded like a very good excuse to finally use metaprogramming, which is one of the more cooler features for Moose, which I'm going to show you now. So we want to dynamically generate an application every time we run this command. The front end is very simple, it does nothing. It's just an empty script that loads some module and then calls new environment. That's basically how any modern or post-modern or whatever Perl script should look like. Load everything off into a class, initiate an object of that class, and then run it. Everything is handled in this class, which is much easier to test it, because it's just a regular class that you can use all of the wonderful Perl tools for testing that class. So we have this thing called TimeTracker Proto, which is the class that generates all the other classes based on the current config. And the run method, which is called by the script, basically looks like this. Too big here. We load some configuration, we'll go into that later. Basically the configuration, among other things, contains a list of plugins. Then we use Moose Meta class, which is the basic Moose Meta object framework thingy to initiate a class. And we want to create an anonymous class and store the anonymous class into this object. We can also tell this class that we now generated to have some superclasses. In this case, the superclass should be TimeTracker, which means the other way around, which makes more sense. the class we now generate is a subclass of TimeTracker. And we can also apply some roles. And that's basically just a list of things. One is the core role, which is out, it's a random string generated by Moose. But on that class we call now with options and then run to actually run the dynamically generated class. Yeah. Yes?
Where does the run for the dynamically generated class come from? Is that from your core?
No, that's from TimeTracker itself. So there's a proto class which has a run method, and then there's the TimeTracker which has another run method, which I'll show you in a minute. So now one thing that's missing is how the configuration is set up, which is a little bit boring. It's just a basic file getter that looks into your current working directory, goes up all directories, looks for a special config file called .tracker.json. All of those config files are merged using the wonderful hash merge into one hash. And hash merge makes it easy to have values overwrite each other or amend each other, and so it's very nice for that. And at last, we merge the default configuration file that lives in your home directory. So for example, I always want to use this sync via Git plugin for my project, which allows us to sync those tracking files to different machines using Git. So in my basic configuration file, I use this thing. I keep all of my job-related projects in one directory called Active or something. And for that job, I always want to have those plugins, keep it the RT plugin. And for some other projects, I want to notify my colleagues via IRC. So in that project, I add this thing here. And now this configuration parser goes all through, collects it, merges it, and then in the end I have one list, which in that case would consist of sync via Git, RT, Git, and goes to IRC. And of course, depending on where I am in my file system, different of those track files are found and merged, so I can use different things. And different dynamic classes are generated. So now how to run it, that's earlier, the run method in here. This is implemented in this super class at TimeTracker. Yeah, I said earlier. It's not very interesting, it just basically gets the command name from RP, that's a little bit hacky. And then calls a method called command_command. So if I run start, the method that actually implements it is called command_start for reasons I'll show you in a minute. So each command itself is again implemented as a role. It's a method provided by a role. The core commands are in command core. They're not very spectacular, they're just do stuff. For example, it's a start command. Yeah, it's just does stuff that's just not very interesting in the end. But as you can see here, those commands also take options like add project tags and whatever. So how do we get these options? This super class or the base class of TimeTracker uses musicScattered. And musicScattered makes it very easy to set up attributes you can find in your classes via the command line. So basically all the attributes you have in your class are now available via the command line, because you can exclude some in the implementation of musicScattered. In fact, you don't have anything but to apply the musicScattered role to your class, and that's it. And one thing that's important, you have to init your object with new with options, not new but with options, which is a special way to tell musicScattered to actually pass RGB like this. But the problem here now is that not all of those options apply to all the commands. For example, start and stop with an option at. I started at that time, or I stopped at that time. Start at 10 o'clock. Because for example, when you forget to click the start button, then the data option but other commands don't need that option. And maybe one command requires a specific option. It requires it, and another command doesn't want that option to be set, so it's a little complicated to get all of those attributes right. So the solution, of course, is more metaprogramming. Because just as like in dynamically generate a class, you can also add methods and attributes a regular class or to an anonymous class at runtime. It looks like this. Going through it. The first block here is just to show some more introspection methods, get all method names, which is called a method data class object, returns the list of all methods defined in the class, and we iterate over these things and look for methods that are actually commands. That's the reason why these command methods are named command underscore something, so I can find them and don't get some helper methods that are really easy to use this. Just stores all of the available methods that are defined by the plugins, which define the Twitter class. Now then we get RQE, the command line thing, and now we have to promise that the proto class, which this thing is part of, doesn't really know, cannot pass the command line, because the command line has to be passed by the dynamic class that's generated later, because the dynamic class defines the attributes for this command. So we now have to actually manually go through argv and look for stuff that looks like a command. Of course, if you have an option of a project that means that's started, it would be a problem. Don't think your project is start. Now, if you find one of those commands, then we set a special string. It's called load attributes, which basically is the method name we want to call to load the attributes for this dynamically generated class. And then you can check with as methods if this class actually implements the thing. That's basically the same as if you do can, only it's nicer. Because and if it does, then we can just on that class, which is the anonymous class, call this class method actually with the class. This is how we then actually load the class. It's some basic methods. It gets the class name, which would be some anonymous class name we don't care about, and the meta class, which is the object that contains information about the class. And then call on this meta object, we call add attribute. So okay, into this class store the attribute, and that part is just like the regular moose declaration. It's exactly the same as you would use if you say as something. So now the dynamically generated class based on some config values with matching attributes that can be set to the command line. Yeah, nice and shiny. But one thing is missing, the plugins, how do we actually implement the plugins? As we're using Muse, it's quite natural to use roles as a plugin. That means to implement a plugin-like behavior. Can you read it? In fact, it's too small.
It's okay.
But the code is big as well. It's the one part start anyway. So you remember from earlier when we said when we initiate the anonymous class, we have roles and then this list of stuff. So that's how we define which roles this anonymous class should have. One very easy plugin to see how it's implemented is the simply a Git thing, because it makes it very easy to manage all your tracking files versus Git. So if I want to sync from that laptop to my work machine, I just say tracker sync and then it synchronizes the stuff using Git events. So you need to turn the tracker into a Git repository, Git stuff, and then you can say tracker sync. That's the implementation of that thing. It's not very fancy. I'll go through it. It uses a Muse role. It uses Git repository. There's a talk on this thing later by book. So you want to see how you can wrap a Perl report Git repository in Perl with that talk. The rest is not very interesting. It's just how do you interact with the Git stuff and interchange it. So this is a very simple plugin that adds a command. But we also often not want plugins to alter or amend an existing command. For example, during start also with Git branch. So this is implemented using a wonderful Muse feature called method modifiers. Where you can pack some stuff around the method. So this is, for example, the Git command. Again, alright. And it has a branch. So it defines its own attribute. It's only valid for this command. And then we say it after command starts, which means that after the regular start command is run, this code block is going to be executed. Okay. You can see Muse expanded method modifiers for other method modifiers that are available. So now we can say tracker starts some branch to a config and get started working on the thing and switch to a new branch. Only, of course, if you have used the Git plugin in that configuration. If you don't, you get a warning saying, I don't know the attribute branch. So what you can do, you can fancy stuff. For example, I told you there's a plugin to talk to request tracker, to RT. Given an RT ticket number, if you go to the web API, get information from the request tracker and store it in ticket. And it's also it will be very cool if you use that number, the information to generate a branch name, which you can, of course. It looks like this, that's the total thing. So we use RT client REST, which is the API, the client to interact with RT. Unicode normalize. Again, an attribute is only valid for this command. This is RT, which takes the RT number. Has some other features which I don't talk about. And here again, I say before any of those commands is run, so you can, just as you can define several attributes in one go, you can wrap several methods in one go. So before one of those commands is executed, do that, which does some other cool RT stuff, which I just don't have time. But in the end, it says, oh, does this class have the role at time if the command git loaded into it? If it has, great, then we can set the branch to a nice thing like RT ticket number and the pretty printed version of the name of this ticket. And then set the branch, which is implemented in that plugin thingy, which is here. So now we can say tracker start IT 1234, and that started working on uptime, blah, blah, switch to branch IT 1, and blah, blah. Okay. Very nice. So TimeTracker does all of this a little bit more. Oops, sorry. Like, for example, talking to IRC or to some other systems, sending HTTP requests off, notifying people that something happened, sending notifications to your window manager. So, for example, you have a nice thing on your thing that says, you're working at the moment or you're not working. Of course, a lot of stuff for reporting to actually get the time out and then tell you also your customer how much money you want. Could do a lot more if somebody feels a certain need and writes a plugin. They go to GitHub and CPAN. Use it. Any more questions or do you want to move?